Good morning, Year 10. Starter, as per normal this morning, we're going to be carrying on with dealing with volumes and pyramids and cones later on, but just to get you through your starter, 8x plus 11 equals 21. Solve. Factorise 8ac plus 4a squared c. Factorise a squared minus 16, sorry, that's my little mistake there, that should be an a in there. So it's a squared minus 16a plus 39. Calculate 12 divided by 2 and add an 8 minus 6 inside a bracket, but that bracket is squared. That's a big mess question. Calculate the volumes. So you've got a triangular prism. You've got the dimensions that you need to calculate the volume. You've got an L-shaped prism here. So you've got the height there, you've got the width, you've got 3 centimetres is the height of this part. Okay, so that's 3 centimetres, and 3 centimetres is the depth here as well. So you've got enough information there to find the area at the end. Don't forget that then the depth of the whole prism, the depth of the whole shape is 2 centimetres. So what is the volume? You want to pause your video now, copy those questions down, and then do your solutions, and then you can come back and I'll go through the solutions for you. Right, the solutions. Solving. 8x plus 11 equals 21. What's the value of x? So, subtract 11 from each side of the equation. Subtract 11 leaves me with 8x equals 10. Divide both sides by 8, so x equals 10 divided by 8. So that is 1 whole, 1 and 2/8 left over. So x equals 1.25, 1 1/4. Factorise 8ac plus 4a squared c. What is common to both of those terms? Both of those terms contain a 4. Both of those terms contain an a. Both of those terms contain a c. So the first term, if I take out a 4, 4 times what takes me back to 8, so that's a 2. We've taken out an a, we've taken out a c, so that's all that we need to put inside the bracket. Taking out a 4, we've taken out one of the a's, so we need another a, and then we've already got a c, so that is our solution, 4ac bracket 2 plus a. Quadratic expression, so 2 brackets straight away, an a in the front of each bracket. What two numbers multiply to make plus 39 but add to make minus 16? It's got to be two negative numbers, ladies and gents. So to make plus 39, it's going to be a negative 13 and a negative 3, negative 13, negative 3, put them together and we do get a negative 16. Big maths. Brackets. So if we do our brackets, 8 minus 6, 8 subtract 6 is 2. But we've still got a squared on that. We've got a division here, 12 divided by 2, 6. 6 plus 2 squared, 6 plus 4, our solution is 10. Calculating the volumes. What is the area? Cross-sectional area of the prism. Half times base times height gives us the area of that triangle. So half times base times height gives us 6 centimetres squared for that area. 6 times 7 gives us the volume. 6 times 7 equals 42 centimetres cubed. A little bit more to this one. We've got to find the area of this L shape at the end. The area, 3 centimetres by 3 centimetres, so that's 9 centimetres squared. 5 centimetres, and that's got to be 3 centimetres as well, because we're 6 centimetres the whole length, we're taking away 3. 3 times 5 gives us 15 centimetres squared. 15 centimetres squared plus 9 centimetres squared gives me 24 centimetres squared for the area. 24 times the length, the volume is 24 area by the length, the depth of the shape, gives us 48 centimetres cubed. Right, moving on to the other board then. Yesterday we talked about reminding ourselves about the volumes of prisms. We've done a couple of starters now, just reminding ourselves about that. On Monday the lesson was about finding the area of the volume of cuboids and prisms. So we've had quite a lot of revision about that. We then moved on, discussing a slightly more complicated example there that I'll work through with you. And we moved on to dealing with pyramids and cones. So pyramids and cones. Again, make a note of these formulae. For a cone, base times the height, divide that by 3, and that gives us the volume of that shape, the cone. Don't forget the area of the base, pi r squared. Okay? That distance is r. Okay? Area of the base, which is a circle, times the height, the vertical height, divide that answer by 3, and that will give you the volume of that shape. Similarly with the pyramid, you did some examples on this yesterday. Find the area of the base, multiply it by the vertical height, divide it by 3, and that gives you the volume. We did a couple of examples yesterday on those. We solved those just as something slightly different. The volume of that cone is 150. So the volume is 150 centimetres squared. That would be equal to pi r squared times the vertical height, which we don't know. That's what they're asking us to find. Okay. Now I'm going to make things simpler. I'm going to take the value of pi again as 3. So we can say 150 equals 3 times, what's r? 6. So 6 squared is 36 times the vertical height. So we can now say that the height is 150 divided by 3 lots of 36. 3 lots of 36 is 108. And that is what would give us our height. So our height is going to be roughly 1.4, something like that. 1.4, 1.5, it's going to be between there somewhere. We can work that out if we had a calculator, and that would give us our height. So all we're doing is we don't know the height. Oh, I forgot something here, haven't I? I forgot that we've got to divide that by 3 as well. Oh, there you go. Lucky I realised. That would have to be divided by 3. So let's write that in again. So 3 for pi, 36 for the r squared times h. We've got to divide all that by 3. That makes life a little bit easier actually, because that means that the height equals 150 divided by 36. 150 divided by 36. But it's going to be sort of roughly 4.2, something like that. But you can work that out on a calculator. But that's just how you approach that type of question. So the questions today that I'm asking you to deal with are going to be dealing with the volume of the cone. I'm going to give you something else, another piece of information. You might want to make a note of this. The volume of a sphere. So a ball. The volume of a sphere is given by this formula. Volume 4 pi r cubed divided by 3. So make a note of that, because that might come up in 1 or 2 of the questions over the next couple of days. It's just about plugging in your values. R is that distance from the centre to any point on the outside of your sphere, the outside of your ball. Pi is the same as what you'd be used to. It's on your calculator an accurate figure of pi. So 4 pi r cubed divided by 3 is the volume of the sphere. That might come up on some of the questions over the next couple of so it's quite a short presentation. You've had a starter. I've just quickly gone over those formulae for you. You need to make sure you've got a note of that for